on this graph, we are increasing from left to right, just like how we read on these two sections. And like I said, we're only considering what that means with the x values. Because by saying word increasing, I've already established that we're dealing with the y's going up. So if you imagine that we're doing domain, the leftmost part is an arrow going to the left, so that would be a negative infinity. Then I get to this first stopping point where it changes from increasing to decreasing, and that happens at an x value of -1. Then I have another piece of my graph that increases, and it starts at an x value of 3. And then my arrow is going to right, so that increases forever, so positive infinity. Since there's two pieces of my graph that increase, that means my interval notation is going to have two pieces. Notice that the 4, it's at 4 and down at -4, does not come into play, because when I say when, I'm talking about x values. So let's clean some of this up a little bit. So if I've talked about increasing, the next logical thing to ask about would be decreasing. So decreasing means on my graph we're going down from left to right. Or you could think of it as a negative slope. Since decreasing means we're talking about the y values going down, I'm asking where is it between what x values are my y values going down. And that's happened from -1 to +3. One thing you can do is, if you notice, I have these same numbers happening in my increasing and decreasing, and as long as my function doesn't have any gaps, you should be covering all numbers. So -1, or negative infinity, -1, -1, 3, -3, positive infinity. Everything should be covered if there aren't any gaps in your picture. Okay, so that's one way we can describe functions. If it was constant, then that's basically means flat. So let me erase some of this. So flat would just look like horizontal lines, so I'll show that with this orange piece. So if we had something like that, that would be a constant. Just flat and boring. Okay. After we talk about increasing and decreasing and constant, we have positive and negative. The positive means where is my function above the x-axis? Where is it above the x-axis? And if I look, there are two places where that's happening. This piece is above the x-axis, and this piece right here is also above the x-axis. So if we want to say where it's positive and negative, and in my notes I did in a bunch of different colors, but we're just going to go with these colors for now. So positive has two pieces, and it's from -3 to 1 union +5 to positive infinity. If we're talking about negative, that means where is it below the x-axis? Below the x-axis. Once again, we have two pieces. So negative, where is that arrow going? It's going left. Don't think about it going down right now. It's going left, so negative infinity. Then it stops being negative at -3. Union starts being negative again at 1 until 5. Another thing that we'll talk about more in class is, if you notice, everything with increasing, decreasing, positive, negative is with parentheses, because at the exact moment that it's changing right here, it is exactly 0. It's not positive or negative, it's exactly 0. So that's why that's parentheses. And once you get to calculus, you'll learn about what is happening when it changes increasing to decreasing. But it also means that increasing, decreasing, we're going to use parentheses, not brackets. Okay. So let's clean this up and talk about one more thing, which is end behavior. If you can just learn this one little thing about end behavior, your life will be very happy. And one thing you need to know about end behavior is that it always starts exactly the same. Before you even look at your graph, your structure for end behavior starts the same. And that is, the first part of your end behavior is as x approaches negative infinity, blah. And then x approaches positive infinity, blah. And you could think of this as what is the left side doing and what is the right side doing. It always, always, always starts with x. And it's x goes to negative infinity, x goes to positive infinity. Then you fill it in. Well, if we've already dealt with x, that means the other part is y. And we read these little arrows as going to. And all you have to fill in is if y is going down, you put negative infinity. And if y is going up, you do positive infinity. So if we're looking at the left-hand side, is the left going down or up? It's going down, so that would be negative infinity. Then if we look at the right, is the right going up or down? The right is going up, so that's to positive infinity. There also would be situations where it's flat and it's just going to a number, like y going to 4. That would look like if, let's see, y going to 4. If instead my graph went like that. Okay. We'll talk about all these more in class. That's just a quick overview.